Hi students, very good morning to all. Today we are going to discuss one of the most important energy storage devices used in modern technologies, like batteries. From smartphone to electric vehicles. Not only from that smartphone to electric vehicle, it also used in satellites, medical devices, renewable energy systems, etc. But battery plays the major role in our daily life and engineering applications. Just we think about without batteries, many modern electronics and electrical system cannot be functions. So a battery is an electrochemical device that can be converted from chemical energy into electrical energy through redox reaction. So redox reaction, it's nothing but both reduction and oxidation takes place simultaneously. So the performance of many modern technologies depends on the battery parameters, especially the parameters may be energy density, power density, then charging speed, lifetime of the batteries, safety, and environmental impacts like that. Why they, especially in engineering student to study the storage devices? Because the engineering students should understand the batteries is very important because they are closely related to electronics and electrical system as well as material science, technologies, renewable energies, electrical mobility, like that. So in this section we are going to discuss about what is battery, what is cell, and also what is the basic principle involved in it, then what are the components present in the battery, then types of battery followed by requirements of battery, then charging as well as discharging, that time what type of chemical reactions occurred inside the batteries, then followed by applications. So these things we are going to discuss about in the topics. So simple introduction about the batteries, in batteries or maybe the electrochemical cells, the chemical energies may be converted into the electrical energy. Chemical energy converted into the electrical energy. So it mainly the cell potential is related to free energy change. Cell potential is related to the free energy change. In electrochemical cell, the system does work by transferring the electrical energy through an electrical circuit. The system does work by transferring the electrical energy through an electrical circuit. Hence, delta G for a reaction is a measure of maximum useful work. Delta G is a measure of maximum useful work. So, that can be obtained from a chemical reaction. It will be mentioned as delta G. Delta G. G is the free energy. The G is the free energy. Delta means change. Delta free energy change. Delta G is equal to maximum useful work. Maximum useful work. So we know very well the maximum useful work, it's nothing but maximum useful work, it's nothing but NFE. N means number of electrons loss or gain. Loss or gain. F means Faraday. Faraday, 1 Faraday is equal to what? 96500 coulombs. Then E means electricity. E means electricity. So this delta G, it's nothing but the maximum useful work, but the maximum useful work is nothing but NFE, number of electron loss or gain, Faraday with electricity. So when a cell operates, work is done by the surrounding. Cell operates, work is done by the surrounding. That is called flow of electricity. Flow of electricity. So this flow of electricity we should mention delta G is equal to minus NFE. Minus NFE. So the decrease in free energy change. Decrease in free energy change is indicated by the negative sign. Or otherwise, we should write like this: delta G is equal to less than 0. Delta G is equal to less than 0. So it's one of the main uses of galvanic cell is the generations of portable electrical energy. That part is known as the batteries. So now we are going to discuss about what is the battery, what about the cells, then what about the requirements followed by types of battery. So what is the battery? Battery is an arrangement of several electrochemical cells. Arrangement of several electrochemical cells connected in series. Connected in series. So several electrochemical cells are connected in series. That is called batteries. So that can be used as a source of direct electric current. That can be used as a source of direct electric current. So battery, what is in the battery? Battery is an arrangement of several electrochemical cells are connected in series. Now, what about the cell? What about the cell? What is meant by cell? What is meant by half cell? Then what is meant by battery? These are all basic components to study the storage devices. So we know very well battery. Battery is the number of electrochemical cells are connected in series, that is called battery. So what is meant by cell? What is meant by half cell? Cell, it's nothing but single anode as well as cathode. Single anode as well as cathode. This may be a silver electrode. This may be the copper electrode. So this one is silver electrode. This one is copper electrode. So the silver electrode may be immersed in corresponding salt solution, may be silver sulfate or silver nitrate or silver chloride, like that. Same copper electrode, maybe it will be immersed in copper sulfate solution or copper nitrate solution or copper chloride solution. So these both electrodes are connected with voltmeter, that is called full cell. So what is meant by cell? Single anode as well as cathodes are connected in voltmeter, that is called a full cell. So half cell, it's nothing but single electrode immersed in corresponding salt solution. For example, this zinc electrode, this may be the zinc electrode, it's immersed in maybe a zinc sulfate solution or zinc nitrate solution. Zinc nitrate solution. This types of setup is called a half cell. So we know very well what is meant by half cell, what is meant by cell, what is meant by battery. Is it clear? Okay. Next one, requirement of battery. Requirement of a battery. So the requirement of battery, it's nothing but a useful battery should fulfill the following requirements. What are the requirements? First requirements. For example, this requirement may be first one, first points, it may be a lightweight. Lightweight. Lightweight means what will happen? It can be easy to transport from one place to another place. So that is the first requirement. Lightweight, then it can be easy to transport. Then it should have a long life. It should be a long life. It should be a long life. When it is being used or not in used, that time the voltage of the battery should not vary. So it should be a long life. Then third one, the voltage of the battery should not vary with the time to time. So the stable voltage of the battery should be more stable. So these are all maybe the requirements of a battery. This three criteria is fulfilled means it will be act as the good battery. Is it clear? Lightweight, that's why it will be easy to transport. Then it will be a long life. It will be act as a good battery. Third one, the voltage of the battery should not vary with the time to time. So these are all maybe the requirements of battery. The next one, types of battery. So based on their working, the battery usage, it can be divided three types. One is primary battery, another one is secondary battery, third one is tertiary battery. So primary battery, it's nothing but types of battery. Types of battery, it's nothing but based on the usage, it can be divided three types. One is maybe a primary battery. Primary battery. Next one, secondary battery. Third one, tertiary battery or flow battery. flow battery. So first one, primary battery. What is primary battery? This another name may be a primary cells or non-reversible battery. So that word have meaning, non-reversible battery. In the cell, the electrode reactions cannot be reversed at the time of passing electricity. Electrodic reactions cannot be reversed at the time of passing electricity. Such a type of batteries are primary battery. It reveals that what? The reaction occurs only one time. The reaction occurs at only one time. Then after they use, they become dead. After they use, they become dead. So therefore, they are not rechargeable. They are not rechargeable. These types of batteries are primary battery. Best example may be a clock battery, like a dry cell or Leclanche cell. Now, secondary battery. This just reverse to the primary battery. In the cell, the electrodic reactions can be reversed at the time of passing electricity. The electrodic reactions can be reversed at the time of passing electricity. So these types of batteries are secondary battery. It reveals that what? This are also maybe working time, it will be a completely discharging takes place. Then after dry, when you put the charging, again it will becomes to the original form. Again and again we have to reuse. So that's why the definition may be like that. The electric reactions can be reversed at the time of passing electricity. That is called a secondary battery. So these are rechargeable battery. These are rechargeable battery. Rechargeable battery. Example, number of examples are there, but here I should write only lead acid battery, then nickel cadmium battery, then lithium battery, etc. Then third one, flow battery or tertiary battery. Another name may be a tertiary battery. Flow battery or tertiary battery. In this case, the reactants, products and electrolytes are continuously passing through the cell. The reactants, products and electrolytes are continuously passing through the cell. Here chemical energy converted into electrical energy. Chemical energy converted into electrical energy. So this is called flow battery or tertiary battery. Flow battery or tertiary battery. Here example may be hydrogen oxygen fuel cell. Best example, hydrogen oxygen fuel cell or sulfur oxygen fuel cell. Sulfur oxygen fuel cell or sometimes methanol oxygen fuel cell is also maybe give the example for flow battery or fuel cell. Okay. How many types? Three types. Based on their usage, the batteries are divided three types. One is primary, another one is secondary, third one flow battery. So primary battery, it should be the electrodic reactions cannot be reversed at the time of passing electricity. That is called a primary battery. Example, dry cell or Leclanche cell or mercury cell. Then secondary battery, it's just a reverse for primary battery. The electrodic reactions can be reversed at the time of passing electricity. That is called a secondary battery. Best example, lead acid battery, nickel cadmium battery, lithium sulfur battery, lithium ion battery, like that. Then third one, flow battery. Here the electrode, it means in the cell the reactants, products and the electrolytes are continuously passing through the cell. So here the chemical energy is converted into electrical energy. So the best example is hydrogen oxygen fuel cell, sulfur oxygen fuel cell, methanol oxygen fuel cell, like that. Now we are going to discuss about primary battery with example. Primary battery with example. This is the simple experimental setup for primary battery. So it is the primary battery which works without fluid compartment. Because all the components should be in the solid. So that's why it should be works without fluid compartment. So simple experimental setup. Here a dry cell consists of zinc cylinder. The outer surface should be a zinc cylinder. So this one is the zinc metal. Zinc cylinder which act as anode. Anode means what? Negative. So for electrochemical cell, anode means general form like E cells equal to E anode minus E cathode. So cathode means positive, anode means negative. Anode means oxidation takes place, cathode means reduction takes place. So this is the simple formula to remind the electrochemical cell. Anode means always negative. Anode means oxidation takes place. Cathode means positive. Cathode means reduction takes place. That is called a electrochemical cell. That is called a electrochemical cell. So here zinc metal, it should be a dry cell consists of zinc cylinder which act as the anode. So the zinc cylinder filled with an electrolyte containing these are all the components. It's a mixture of manganese dioxide, graphite, ammonium chloride as well as zinc chloride. It's the combination of these four things. It should be used inside the zinc cylinder. So this all the things using starch as well as water converting to paste form. Starch as well as water converting into paste form, then get dry. That things should be packed inside the zinc cylinder. Then one more thing, a carbon rod, that is this one. Carbon rod, it should be act as cathode. Carbon rod should be act as the cathode. It should be immersed in the electrolyte in the center of the cell. It should be immersed in the electrolyte in the center of the cell. So this is the simple experimental setup. Here zinc metal act as the anode, carbon may be act as the cathode, like remaining the electrolyte substances may be the mixture of manganese oxide, graphite, ammonium chloride, zinc chloride, like that. It should be mixed with small amount of starch as well as water, converted into the paste form. Then after dried, it should be packed inside the dry cell. So this is the simple experimental setup. So the zinc cylinder has an outer insulation of cardboard case. During use, the zinc cylinder get consumed and at the end. So it will develop the holes which is responsible for some leakage. So simple working about the Leclanché cell or dry cell. When the cell is working, zinc lose the electron, because we know very well what is the anode. Anode means loss of electron takes place, cathode means reduction takes place. So anode means negative charge, cathode means positive charge. So when cell is working, zinc loses the electrons and zinc 2+ ions may be formed. So the electron passes through the circuit. These electrons may be passes through the circuit, then it will be consumed by the cathode. So this causes the discharging of ammonium ions from the electrolyte. This causing the discharging of ammonium ion. Here ammonium chloride is there, ammonium ions. Ammonium ions, NH4+. Discharge of ammonium ions from the electrolyte. So what are the chemical reactions possible inside the dry cell? So next one, the chemical reaction, cell reactions. We know very well what is the anode. Anode means what is the metal should be act as the anode? Zinc metal. So for anode, zinc is converted into zinc 2+ plus 2 electrons loss. So that is the anode. Then we know very well the battery working time. The electron lost by the anodic part, that electron gained by the cathodic part, it will get reduction. Anode means oxidation takes place, cathode means reduction takes place. So in cathodic part, what are the things are may be used? Cathode, we already used MnO2 plus ammonium ions plus 2 electron lost by the anodic part gained by the cathodic part, it will get reduction. So MnO OH minus plus ammonia. Okay. So this is the cathodic part reaction. Now we should write the overall reaction. Overall reaction. How to write overall reaction? Simply we should cancel the opposite terms. 2 electron cancel. So we should write zinc plus MnO2 plus NH4 plus gives MnO OH minus plus NH3. So this is the overall reactions possible inside the dry cell. Now how to say it is the redox reaction for cathodic part? Anodic part, it's well known. Loss of electron is the anodic part. Zinc converted into here zinc is converted into zinc 0 converted into zinc 2+. That is called oxidation anode. What about the cathode? Here MnO2 ammonium plus, then 2 electrons capture from the anodic part, then it will get reduction. How it is say it is the reduction? Simply you see that MnO2 single oxygen is the 2 minus. Here 2 oxygen is there, so it should be a 4 minus, it should be a 4 plus. What about here manganese oxidation state? Here already 1 minus is there. Here single oxygen is there. Here 2 minus. So totally 3 minus. So it will be a 3 plus. Is it clear? So manganese converted from plus 4 to plus 3. So it is called a reduction. Is it clear? So that is the cell reactions possible inside the dry cell or Leclanche's battery. Now, some quantity of ammonium gases is produced. What will happen? In the cathodic reaction, manganese is reduced from plus 4 to plus 3. But it's the meantime, the liberations of some quantity of ammonium ion to ammonia. This ammonia. What will happen? This ammonia will disturb the current flow. This ammonia will disturb the current flow is prevented by a reaction with zinc chloride. That's why we already mixed with it like electrolyte, manganese dioxide, ammonium chloride, zinc chloride, starch and water, graphite, starch and water. So that zinc chloride already present in the uh, electrolytes itself, that zinc chloride reacted with liberated ammonium gas. What will happen? It will be a form that stable complex like zinc amine complex, zinc chloroamine complex, zinc chloroamine complex. So it will be due to the formation of this complex, it will uh, prevent the current flow. So this is the uh, prevented by the reaction of ammonia with zinc 2 plus ion from zinc chloride. So it will be a form the stable complex. So it will prevent the electricity flow. So for dry cell, the voltage of dry cell is about near about 1.5 volt. 1.5 volt. So what are the advantages? These advantages may be used in that batteries may be used in clock battery, toys, torch, mobile phone, like that. Sorry, not mobile phone, toys, clock battery, then uh, some of the torch lights like that. Then it has some disadvantages. Why? Because it is the dry cell does not have any indefinite life. Does not have any indefinite life. So that is the first point. Indefinite life. So because ammonium chloride being acidic nature, so automatically it will corrode the container, zinc container. That is the first point, first disadvantages. Next one, when current is drawn rapidly from it, it produces buildup on the electrode. So voltage drop may be occur. Voltage drop may be occur. Voltage drop may be occurs. So these are all maybe the cell reaction, advantage and disadvantages of dry cell. So what are the advantages? It may be used in clock battery, clock, toys, um, like that. Then torchlight like that. Then third one is disadvantages. Having few disadvantages. It does not have any definite life. It have the indefinite life. Then voltage drop also occurs when the current is drawn rapidly from it. It products build up on the electrode, so voltage drop may be occurs. So this is the dry cell or Leclanche cell. What we discussed from this initial for a dry cell, what is the experimental setup, then followed by cell reaction, then advantages, then disadvantages. Now the presently available in the market like alkaline battery or dry cell, this is the available in the market from alkaline battery or dry cell. Okay. Next one, secondary battery. Next we will move to the secondary battery. One example like lead acid battery. Secondary battery, lead acid battery. So lead acid battery, it's the best example for secondary battery. So simple experimental setup. And before that, we know very well what is the secondary battery. The electrodic reactions can be reversed at the time of passing electricity. It reveals that what it can be used again and again. It can be used again and again. That's why it will be called a secondary battery. Best example, lead acid battery. or otherwise lead accumulators or lead storage cell, another name. Lead accumulator or lead storage cell or lead acid battery. So the lead storage cell is a secondary battery which can operate both voltaic cell as well as electrolytic cell. Voltaic cell, it's nothing but voltaic cell, another name may be a electrochemical cell. So voltaic cell or electrochemical cell. Electrochemical cell. Electrochemical cell or another name voltaic cell. One more thing, electrolytic cell. So voltaic cell or electrochemical cell, it's nothing but the chemical energy is converted into electrical energy. Chemical energy converted into electrical energy. But the electrolytic cell, it's nothing but electrical energy converted into chemical energy. Electrical energy converted into chemical energy. So from this explanation, what you have to conclude, when the cell is working time, the chemical energy is converted into electrical energy. That is the working time. That is called the electrochemical cell. That is called the electrochemical cell. Electrochemical cell. What about the electrolytic cell? Electrical energy converted into chemical energy. Electrical energy converted into chemical energy. So now we are putting the charge to the battery. It's time the electrodic reactions can be reversed. So that is called electrolytic cell. So this is the simple difference between electrochemical cell as well as electrolytic cell. Now, what is the experimental setup for lead acid battery? Experimental setup for lead acid battery. This is a simple setup for a lead acid battery. Lead acid storage battery consists of a number of voltaic cells are connected in series, near about 3 to 6 voltaic cells. 3 to 6 voltaic cells are connected in series to produce near about 6 to 12 volt battery. 3 to 6 voltaic cells are connected in series. 3 to 6 voltaic cells are connected in series to produce 6 to 12 volt battery. 6 to 12 volt battery. 6 to 12 volt battery. So the cathode is here. The cathode is made up of lead. So lead is cathode. Then one more thing, anode is made up of lead dioxide. Anode is made up of lead dioxide. So lead is cathode. Lead is anode. Lead is anode. Lead dioxide is cathode. Lead is anode. Lead dioxide is cathode. For in this case, a number of lead plates are connected in parallel. You see that these are all the lead plates. This one, then this one, then this one. So these three things are lead plate. So the number of lead plates are connected in parallel, and also number of lead oxide plates are also connected in parallel. The black shade, it should be the lead oxide plates. So number of lead plates are connected in parallel, as well as number of lead oxide plates are also connected in parallel. So these various plates are separated from the adjacent one. Various plates are separated by adjacent one, like insulator, like rubber or glass fiber. So the entire combination should be immersed in like diluted sulfuric acid. This is the aqueous sulfuric acid. Diluted sulfuric acid. The density of the sulfuric acid is 1.3 gram per milliliter. So this is the simple experimental setup. Now we have to move the cell reaction for lead acid battery. In before that, we should write the cell representation. What is cell representation? Cell representation, it's nothing but we should write general form, like negative part should be in the left hand side, positive part should be in the right hand side. For negative part may be metal converted into metal plus, :metal plus bar metal. It reveals that what? Metal 0 to +1, oxidation. Anode means oxidation. Left hand side anode means oxidation takes place. Cathode means reduction takes place. So anode 0 converted into +1, oxidation. Inge metal plus, right hand side metal plus reduced to metal. Here already +1 reduced to 0. So that is called a reduction. This one is called a oxidation. This one is called a oxidation. So what about this is the general representation. What about the lead acid battery? Cell representation for lead acid battery. Here, what is the anode? Lead material. Then what is the lead is converted into lead 2 plus. Then double line represent electrolyte or salt bridge. Here, sulfuric acid. Salt bridge may be, sorry, electrolytes may be sulfuric acid. Then what about the cathodic part? Already should be in the lead dioxide. Should be reduced to lead. Here already 4 plus will be reduced to 0. Here already 0 oxidized to plus 2. So this is the cell representation for lead acid battery. This is the cell representation for lead acid battery. Now we will move to the cell reaction. What are the cell reactions possible inside the battery? Now cell reaction we know very well. What is the anodic part? Anode, cathode and overall reaction. Here what is the anode? What is the anode? We know very well, lead material. Then lead is oxidized to lead 2 plus, then it will be combined with sulfur 2 minus, then it will produce insoluble lead sulfate on the surface of the anode. So meantime, 2 electrons may be lost. Why it will be produced like I put the equilibrium arrow mark, double side arrow mark, because it is the reversible reaction, reversible battery. So forward reaction always should be in discharging. Backward reaction always should be in charging. Is it clear? So next one, cathode. So next one, cathode, lead dioxide. What is the anodic part? Already lost 2 electrons. So anode means oxidation takes place. So loss of electron takes place. Now, what is the cathodic part? What is the role of cathode? The cathode reduction takes place it means it gains the electron from the anodic part. So we know very well, cathodic part is lead dioxide. Then it will take the electrolyte from sulfuric acid. It will take the ions from sulfuric acid like SO4 2 minus plus H plus plus 2 electrons lost from anodic part. So what is the product? Here also discharging, here also charging. Okay. So what is the product? Here also insoluble lead sulfate is formed. So meantime 2 mole water molecule as well as electricity is produced. Here I think equation not balanced. So that's why here we put 4H plus. Now it will be balanced. Now, so this is the cathodic part. At the time of it means cathode gain the 2 electron from anodic part, then it will mixed with sulfate as well as H plus ions to produce here also insoluble lead sulfates on the cathodic part. Then in the meantime water as well as electricity is produced. So this is the cathodic part reaction. Now we write the overall reaction. Overall reaction means we should cancel the common terms. So the 2 electrons may be cancelled. So we should write lead plus lead dioxide plus here 4H plus is there. Here is SO4 2 minus. Here SO4 2 minus. 2 SO4 2 minus. So we should write 2 mole of H2SO4. Then here also discharging. Here also charging. What is the product? 2 mole of lead sulfate plus 2H2 plus electricity. So this is the overall reactions in lead storage cell or lead accumulator or lead acid battery. Now, what is this is the discharging time. Battery is working time. This is the battery's working time. From the above cell reaction, it is clear that the lead sulfate is precipitated at both the electrodes, both anode as well as cathode. In this case, the sulfuric acid may be used up. Here, as a result, the concentrations of sulfuric acid decreases and hence the density of the sulfuric acid falls down from 1 point. Density of the sulfuric acid falls down from 1.3 to 1.20 gram per ml. It means that what? the battery may be, so the battery needs to charging, almost get dry, then again the battery need to charge. So next one we should write the recharging the battery. How to write the recharging battery equation? It's a very simple one. The cell can be charged by passing the electric current. What will happen? It will involve the opposite reaction. It will involve the opposite reaction. So it's nothing but the electrodic reactions can be reversed at the time of passing electricity. That is called a secondary reaction. So here the electrode reaction get reversed. As a result, lead is deposited on the anode, then lead dioxide is deposited on at the cathode, and the density of the sulfuric acid is also increased from 1.2 to 1.3. So now how to write the equations? This overall reaction only we are going to write the reverse form. Like a product side should be comes to the reactant side, the reactant side comes to the product side. That's all. Very simple thing. So what is the product side for above reaction? 2 mole of lead sulfate plus 2H2O, this E. E means electricity, external source. Then here charging, because we are putting the recharging the battery, so that's why it should get reversed. So this may be the discharging. Then what is the product? Lead plus lead dioxide plus 2 mole of sulfuric acid. So this is the recharging the battery. This is the net reaction during the charging. Net reaction during the charging time. So these are all maybe the cell reactions involved in lead acid battery or lead storage cell or lead accumulators. So next one, what are the advantages of lead acid battery as well as disadvantages followed by uses? So the advantages, maybe the number of advantages are there. First one, lead acid battery, the fabrication it's very easy to fabrication. Next one, it produces very high current. It produces very high current. Then third one, the self-discharging rate is very low. The self-discharging rate. Self-discharging rate is low, very low. Self-discharging rate is very low. Then fourth one, it is also act as effectively at low temperature. It's more effective at low temperature. It also act as it means more effective at low temperature. So these are all maybe the advantages of lead acid battery. These are all advantages of lead acid battery. Next one, disadvantages. Disadvantages, few disadvantages are only there. So first disadvantages may be recycling of the battery may be causes. Recycling may causes the environmental hazards. Environmental hazards because due to the presence of lead. Then second one, due to mechanical strain, due to strain and normal pumping, strain due to mechanical strain as well as pumping reduces the battery capacity. So these are all maybe the disadvantages of lead acid battery. Then finally, what about the uses? Uses of lead acid battery. First uses, it mainly used in automobiles. It is mainly used in automobiles. Automobiles like cars, buses, trucks, etc. Then second point, it is also used in gas engine ignition, telephone exchangers, then hospitals, power station, etc. So these are all maybe the uses of lead acid battery. What are the advantages? Easy to fabrication, it produces very high current, self-discharging rate is very low, then it will be a more effective at low temperature. Then disadvantages of the lead acid battery is few disadvantages. Recycling of this battery may causes the environmental hazards due to the presence of lead. Trace amount of lead maybe comes out, it will produce the environmental hazards. Then mechanical strain and normal pumping may reduce the battery capacity. Then what about the uses? It is mainly used in automobiles like cars, buses, trucks, etc. Then one more thing, it is also used in gas engine ignition, telephone exchanges, hospitals, power stations, etc. So in this topic, we discussed what about the secondary battery, followed by experimental setup of the secondary battery like a lead acid battery, then followed by what are the chemical reactions, cell reactions possible inside the battery, then followed by advantages, disadvantages, and uses. So next one, third one, flow battery. So this is the secondary battery example commercially available in the market, like a lead storage battery or lead accumulator or lead storage cell. So this is the commercially available battery. Next we move to the third one, flow battery. Flow battery or tertiary battery. What is the flow battery or tertiary battery? It is the reactants, products, and the electrolytes are continuously passing through the cell. Here the chemical energy converted into the electrical energy. That is the flow battery or tertiary battery. Best example, hydrogen oxygen fuel cell. Hydrogen oxygen, a lot of flow batteries are there. Hydrogen oxygen fuel cell, methanol oxygen fuel cell, sulfur oxygen fuel cell, like that. But in this case, we are going to see only one example, like hydrogen oxygen fuel cell. So what is in the fuel cell? The fuel cell is a voltaic cell which converts the chemical energy of the fuels directly into electricity. Chemical energy of the fuels directly into the electricity. That is called a fuel cell. So the fuel cells converts the energy of the fuels directly into the electricity. In the cell, the reactant products and the electrolytes are continuously passing through the cell. So for example, fuel may be like fuel plus oxygen converted into oxidation product. Oxidation product as well as electricity. So this is the simple working principle in hydrogen oxygen fuel cell. Fuel oxygen, fuel plus oxygen to give the oxidation product as well as in the meantime it will produce the electricity. So best example, hydrogen oxygen fuel cell. What about the fuel battery? Fuel battery. When a large number of fuel cells are connected in series to form fuel battery. Large number of fuel cells are connected in series to form fuel battery. Okay, so that is the fuel battery. Next one, what is the experimental setup for hydrogen oxygen fuel cell? Simple setup. You see that this is the block diagram for a hydrogen oxygen fuel cell. So the hydrogen oxygen fuel cell is the simplest and most successful fuel cell in which the fuel hydrogen and oxidizer oxygen and the liquid electrolytes are continuously passed through the cell. So the setup, it may be the experimental setup, it consists of two porous electrode. These are all two porous electrode. This one. Graphite porous carbon electrode. It compressed carbon containing small amount of like silver, platinum, palladium. Silver, platinum, palladium, and gold also. The trace amount of silver, palladium, platinum, gold. Because it will help to activate the surface of the electrode. That's why it should be placed on the surface of the electrode. So in between the two electrodes, the electrolytes may be sodium hydroxide as well as or potassium hydroxide may be used. 25%. This OH, it reveals that what is that? 25% of NaOH or KOH may be used. The two electrodes are connected through the voltmeter. The two electrodes are connected with voltmeter. Here, hydrogen may be used in anodic compartment stage. Then oxygen may be used the cathodic compartment. So hydrogen is bubbled through the anodic compartment where it is oxidized. Then oxygen is bubbled through the cathodic compartment where it is reduced. So this is the simple experimental setup for. So what is the cell reactions involved in inside the hydrogen oxygen fuel cell. So the cell reactions for a hydrogen oxygen fuel cell, hydrogen may be act as the anode, then hydrogen here passes through the anodic compartment, then followed by oxygen is passes through the cathodic compartment. So hydrogen is bubbled through the anodic compartment where it is oxidized. Same oxygen is bubbled through the cathodic compartment where it is reduced. So this is the simple experimental setup. Now working, what is the cell reaction for hydrogen oxygen fuel cell? So first one, anode. First one, anode. Anode, we know very well what is the anode. Anode here, what is the gases is maybe passed in it? Hydrogen gas. So hydrogen converted into 2H plus 2 electron loss. Because anode means oxidation takes place or loss of electron takes place. So H2 converted into 2H plus. Atomic hydrogen, molecular hydrogen. Then this 2H plus is unstable. So again this 2H plus reacted with OH minus present in the electrolyte. Like 25% NaOH or KOH may be used in the hydrogen oxygen fuel cell. That is the OH minus ion. Then it will be converted into H2O. Okay. So here may be the 2 mole, here 2 mole. So what about the overall reaction? Overall reaction. Cancel the common terms present in the equation. This 2H plus cancel. So H2 plus 2OH minus gives 2H2O plus 2 electron loss. So this is the equation number 1. Next, what about the cathode? For cathode, we know very well oxygen is bubbled through the cathodic compartment. So oxygen act as the cathode. So O2, what is the general procedure? Generally, the anodic power lost some electron. That electron gained by the cathodic power, it will get reduction. Then in the meantime, it will produce the electricity. Here, 2 electrons only lost by the anodic part. But here, O2, 2 oxygen is there. Single oxygen required 2 minus. O2 means it will be 4 minus. O2 means 4 minus. 4 electrons may be required. So that's why this equation 1 is multiplied by 2. So this equation 1 multiplied by 2. How to write the equation? 2H2 plus 4OH minus gives 4H2O plus 4 electron. So this is the equation number 2. Now, what is the cathodic part? O2 gain 4 electron from the anodic part. It will be converted into 2O2 2 minus. What is the name? Superoxide radical. Oxygen is converted into superoxide radical, but this one is also unstable one. Again, it will be reacted with O2 2 minus H2O present in the inside the flow battery or fuel cell, because we are using 25% NaOH or KOH. So remaining things may be water. So it should be captured by the superoxide radical because it is unstable, highly reactive. So what will happen? It will be converted into OH minus, like 4 OH minus. So here 2 mole of H2O. So now we cancel the common term. O2 minus cancel. So what about the reaction? O2 plus 2H2O plus 4 electron, it will be gives 4 OH minus. So this is the equation number 3. Equation 3. Now comparing equation 2 and 3. What is the 2? Two H2 plus 4 OH minus gives 4H2O plus 4 electron. Then what about the third one? O2 plus 2H2O plus 4 electron gives 4 OH minus. Now we cancel the common term. What are the common term? Here 4 electron, here 4 electron cancel. Here 4 OH, here 4 OH cancel. Here 2H2O, here 4H2O. So here 2H2O. So what is the overall reaction? 2H2 plus O2 will be gives 2H2O. Okay. So this is the final reaction, like equation number 4. So from this one, we have concluded the produced water. Here, hydrogen oxygen fuel cell, the produced water, it may be more pure form. It will be proved by the valuable sources of fresh water by the astronauts. That is the main application. Then second one, hydrogen oxygen fuel cells are used in auxiliary energy sources in space vehicle because lightweight elements. So space vehicles, submarines, and other military vehicles. So this fuel cell almost produce the battery, means voltage from 0.8 to 1.0 volt. 0.8 to 1.0 volt. Okay. So that is the main application. Only two application, main application, major application. Hydrogen oxygen fuel cells are used as a auxiliary energy sources in space vehicles, submarines, and other military vehicles. Then second one, in case of hydrogen oxygen fuel cell, the product of water is proved to be a valuable sources of fresh water by the astronaut. Next one, advantages. Advantages, number of advantages are there. First advantages may be it will be efficiency is more than 75%. Efficiency is more than 75%. Second point, it emits only water vapor. It emits only water vapor. It emits only water vapor. So zero pollution. Then third one, and hydrogen is the lightest element. It can be transported easily. Transportation easily. Transport easily. Then fourth one, it should be hydrogen as a fuel can replace the use of batteries. Hydrogen as a fuel, it can be replace the use of battery. Replace the use of battery. Next one, it causes the less noise pollution. Causes the less noise pollution. Causes the less noise pollution. So these are all maybe the advantages. What are the advantages? It emits, the efficiency is only, efficiency is more than 70%. Then second one, it emits only water vapor. So there is no any harmful chemicals coming out from this one at the time of running. Then third one, transportation, it's very easy because due to the lightest two elements present in the battery. Then replaces hydrogen as a fuel. It can replace us as the use of batteries. Then one more thing, it produces very less noise pollution. So these are all maybe the advantages. What about the disadvantages? Disadvantages, few disadvantages. It should be highly expensive. Then second one, it should be a open air, highly explosive. Highly explosive. Then third one, as a hydrogen is a gas, it is difficult to compress it. Difficult to compress into liquid form. Compressed into liquid form is more difficult. So these are all maybe the disadvantages. What are the disadvantages? High expensive, highly explosive nature in open place. Then it should be a hydrogen is a gas, so it is very difficult to compress into liquid form. So these are all maybe the disadvantages of hydrogen oxygen fuel cell. Okay. So in hydrogen oxygen flow battery or hydrogen oxygen fuel cell, we discussed what is the experimental setup. Then what about the cell reactions involved in hydrogen oxygen fuel cell, followed by advantages, disadvantages, and applications. Okay. Thank you.